Example 4.1.3. The table shows the daily rainfall R millimeters and daily total hours of sunshine S, which is measured in hours of course, in Tenby for a random sample of 9 days in February 1998. Now you don't need to know where Tenby is to do this question. So there's the data, and you'll see we also have a scatter diagram which comes in later in part D, which actually should be part C. We're told the median and quartiles for the rainfall data, and we are told an outlier is defined as a value which lies either 1.5 interquartile ranges above the upper quartile or 1.5 interquartile ranges below the lower quartile. Our job is to show that an R value of 17.4 really is an outlier. Right, so part A, we need to show that 17.4 as an R value is an outlier. So looking at the R values, it does seem to be unusually large compared to the rest. So we need to look at the upper end of the limits for outliers. We've been told an outlier is either something 1.5 interquartile ranges above the upper quartile or 1.5 interquartile ranges below the lower quartile. But it's not going to be below the lower quartile, so it must be the other end because it's an unusually large number. It's not an unusually small number. So let's do the upper quartile plus 1.5 times the interquartile range. Remember to show that, so we need full evidence. We were given Q3, which is 3.8, and we're going to need to work out the interquartile range, which is the upper quartile, take away the lower quartile. So that's 3.8 add 1.5 times, well, that's going to be 2.8. Put that in the calculator and you get 8. So that means anything bigger than 8 is an outlier at the top, is an outlier at the upper end. So full evidence, so 17.4 is greater than 8, therefore 17.4 is an outlier. It really is unusually large. So here we had a value which is 1.5 interquartile ranges above the upper quartile. If that's true, then we call it an outlier, and we've shown, yep, that is true. Now to part B. Give a reason why you might 1. Include the reading, this 17.4, and 2. Give a reason why you might exclude the reading. So if this was your experiment and you've got this unusually large number, then what are we going to do with it? Well, there are reasons for including it, keeping it in the data, and there are also reasons for excluding it from the data. You need to be aware of both of those arguments, both of those reasons. So pause the video and have a think. Why might we argue that you should include it, and why might we argue that you should exclude it? Well, part 1, a reason for including it, well, it's because it's been recorded data. The experiment was done, that data value was recorded, so therefore we should include it. Just because it's unusually large, for that reason we shouldn't get rid of it. We shouldn't get rid of something just because it's unusually large or unusually small. Strange things happen all the time. So this was maybe just a particularly rainy day. That's entirely possible. So why might we include the reading? Well, it was recorded data, so we should include it. But why might we exclude the reading? Well, extreme values would affect analysis if it was an incorrect reading. Now it's possible that the machine or whatever collected the data for that day was faulty, and maybe 17.4 is actually a faulty reading. So if we learned that that really was a faulty reading, then we would definitely exclude it. But unless we had a reason, like it was a faulty reading, then we would definitely keep it in our data. And now part C, so it's D in your notes, please change it to C. Excluding the day's reading, a scatter diagram to represent the remaining 8 days is shown. Describe the correlation between rainfall and hours of sunshine. So take a look at this scatter diagram. Does there seem to be a trend where it's not very strong correlation, but if we were to draw a line of best fit, it would probably be roughly in that direction. So it's definitely not positive correlation. If there's any correlation there, it would be weak and it would be negative. And all we need to do is describe it. We don't need to interpret it, we just need to describe it. So weak negative correlation is how I would describe part C. You could even maybe say very weak or moderate weak. It's definitely not strong, and it's definitely negative if there is any correlation at all. So weak negative correlation. Look for the word describe in the question. If it said interpret the correlation, then we'd need to say what does this actually mean. If it said interpret, we'd say as the rainfall increases, the hours of sunshine decreases, or vice versa. That's an interpretation. Okay, that concludes example 4.1.3.